Hi everybody. Today we are going to understand the concept of normalization in databases. So what is normalization? The normalization is the process of analyzing your relational tables, okay, your database tables to minimize the redundancy, okay, so that you do not, come across any anomalies. So it's a long thing. Let's try to break down one by one. So normalization is the process of analyzing. Analyzing what? Analyzing your relational tables. Okay, your database relations. You have to analyze this. To analyze this, we are going to take help of the functional dependencies, the FDs, okay, functional dependencies, and the primary key which have been defined on the relations. What is the aim of this analysis? The aim of the analysis is to minimize the redundancy in these relations. Okay. So redundancy in what terms? Redundancy in terms of data, right? So suppose like some information, for example, if you have a student relation, okay, and where you are storing the information of student name and the student roll number. Now the association between a name and a roll number should be stored only once. But let's say you have a design where you're trying to store this information more than once, then that information becomes redundant. Okay, that's what we mean by redundancy. So a normalization is a process of identifying such redundancies using functional dependency in primary keys and reducing it. Okay, now why do we need that? Like, why is redundancy not good? We are going to understand that in this lecture. Okay, now before we go further, now to understand normalization, functional dependency is like a prerequisite for this topic. Just quickly recap what functional dependency means. Functional dependency is nothing but, in short, is the generalization of the concept of keys. I hope everybody understands keys. Keys are nothing but, your super keys, your primary keys. That's keys I'm talking about. So functional dependency is nothing but generalization of that concept. Okay. To explain in simple terms, if I have a relation which has X, Y, and Z attributes, okay, like a relation can be student, and let's say you have X can be a roll number, Y can be student name, and Z can be, the address, right? Something like this. And let's say we say that on this relation, I have a functional dependency X functionally determining Y. Okay, so when you say something like this, now this is a functional dependency which is defined on the relation R. What does it actually imply? Like, what does it really mean when you say X functionally determines Y? Let's just understand that. Let's take an example for this relation X, Y, and Z. Okay, we have 1, 2, 3. Let's repeat 1 here. Let's repeat 2 here. Now, across 1, let's say we have a name, the Pali. On 2, we have some Ram. 3, we have Sonali. 1, I'm repeating the Pali again. And 2, I'm repeating Ram. Okay. So let's say Mumbai, Hyderabad. Let's say Bangalore. Okay. Here repeating, let's say Mumbai. And let's say this is Hyderabad. Okay. Some data is there which we have, right? Now, along with that, you can have one more attributes also, like some another thing like be the passport number, something like that. You can have any number of attributes here, right? I'm saying here X is functionally determining Y. So if you see, whenever I have 1, whenever my X value is 1, my Y value is the Pali. Can you see? Whenever X is 1, Y is also, basically the Pali. Again, there is a 1, it is the Pali. Okay, when you have 2 has a value Ram, again 2 if it is repeating, it has a value Ram. 3 is there, it has Sonali, it has been come only once. So what does X functionally determine Y means? For whatever value of X you agree on, right, you have some value of Y, then anytime if that value of X appears again in the relationship, the value of Y is also going to repeat itself. If that is the scenario for your attributes, you can say X functionally determines Y. Okay, to just give a little bit more example, you could have here, like if you see here, you can have, might be the Pali is also associated with another number 4. That is okay. All right, but because whenever 4 is coming, then the word the Pali is repeating, because we do not have opposite of Y functionally determining X, but we have X functionally determining Y. Okay, here for some reason, here instead of 1 to the Pali, suppose here we had some another name, let's say Rima. then this X functionally determining Y does not hold true, because this holds true when for all the values of X, this thing should be, satisfied. So whenever 1 is Dipali, if it is appeared once, means second time whenever you get a value of X equal to 1, the value should be Dipali and not something else. If it is something else, then you cannot say X is functionally determining Y. To get a more clear or the best example of functional dependencies is the case of primary keys. Right? In the case of primary keys, let's try to understand. Let's just delete this. Okay, so if you see, suppose you have the student relation. Okay, in student relation, we can say the roll number of the person, of the student, can be your the primary key. You have S name, you have some marks for the whatever subjects and whatever marks you have for that subject. You can have some kind of database like this. Now we say roll number is a primary key. Okay, we can write something, roll number functionally determines the student name. What does this mean? That whenever you get a roll number, let's say you have roll number 1, the student name, suppose roll number 1 has a name, let's say Amit. Okay, so anytime you get this data 1, you will always have S name as Amit. You will never have something scenario that whenever roll number 1 comes, at let's say the 4th or the 5th row in your column, you're not going to have 1 will not miraculously change into, say, Seema. That is not the case, right? So when you say roll number is functionally determining a student name, means for whatever value of roll number, the value of your Y attribute is going to repeat. And the best example is of a primary key. I hope that makes sense. Okay, so or you can simply understand your functional dependency is nothing but it is the the generalization of the concept of key. So here we are going to analyze our database relations, your relationals, your relations. You're going to analyze them using the keys, because keys are nothing but constraints on those relations, right? So you're going to analyze them using the functional dependencies and keys to minimize the redundancy present in them. Okay, so this is the entire concept of normalization, right? Now let's try to understand through an example what is the harm of having redundancy in our tables and what kind of anomalies we can actually face. Okay, let's look at an example here, a very practical example. We have a scenario where, let's say, we are a business person and you are dealing with suppliers. You have some suppliers for your some parts, so you have some manufacturing process and you want some parts, and some suppliers are providing you those parts. Now as a part of your company, you're obviously going to maintain data as to who supplier you are in association with and what that supplier is going to provide you what part, correct, and what is the quantity of that part that supplier is providing. Okay, we have some more information on the supplier, like we are also storing information on what city that supplier belongs to. Okay, very the normal scenario. So I just put this together into a table. As you can see on the screen, we have supplier number, the city, the status, part number, and quantity. All right, now for this table or for this relation, I need to have a primary key. Why a primary key? I should be uniquely able to identify every row. Now to do that, here if you see, if I can club together supplier number and part number, okay, the part number and the supply number together, the combination can be thought of as a primary key, because that will uniquely identify each of my row. I hope this is clear. Now let's try to understand such use cases where this this is not a very good relation to follow. The first case is we're going to try to insert some data into a relation. So let's say, suppose we onboard a training supplier. Okay? How you have interns in the companies. Let's try to onboard a training supplier. Let's have a name as S4, and let's say he belongs to a place called Pune. Okay, now because he's a trainee, right, he's going to undergo some training, so he will not supply you any parts until then, right? So what kind of data will you put into your table? You have to insert the data, right? Because now you're associated to one more person or one more supplier, which is your S4, and you need to put that information, that association, that yes, our enterprise is now have one more training supplier, which is S4, because we just have one table here, right? How will data look like? It will be like S4, the city, let's say the person is from Pune. Is there any status now to this person? No. So if you do not know something, and unknown values usually given by null in databases, part number null, quantity null. Think about this for some time. Can I do an insert like this? Will any kind of your like SQL or any kind of relational database, will it, approve this insert? No, right? Obviously not. Why? Because on this table, we have a primary key, supplier number, and part number. You cannot have your part of your primary key as null. That is not allowed. That's one of the main definition of primary key. You cannot have a primary key attribute as a null value. So here, though the data is valid, right? Actually a real use case where I can have a trainee supplier, but I'm unable to, insert that data or insert that association into my database, right? So this is a very bad design of the database. Why am I saying so? It's a valid use case which you're not able to insert. If you look at the database which we have a little closely, you can see the association between S1, right, and the city has been repeated thrice, right? S1 belongs to Hyderabad. This particular data has been appearing in 3 rows. Similarly, S2 belonging to Mumbai is appearing twice. So this is what the redundancy we are talking about. Okay. So this where you are not able to, insert valid data, valid relations inside your relational table is called as insertion anomaly. It's called as insertion anomaly. So now I've identified that I do have insertion anomaly, and the reason is also because I have redundant data, right? Think about it, for some time, like how would you, like, forget you're not a, like, let's say you're not a CS student and you just have this scenario. How would you logically solve this problem? What would you do? Think about it. You would just break down the table into 2 parts. You would say, why not I break down this information into 2 parts? One part is telling me about supplier information, like who is my supplier and what city he belongs to. Another table is going to tell me the relation between supplier and the parts, like which supplier is supplying me what part and what is the quantity it is supplying me, right? And then whatever status I have. So there I'll have S number, my part number, my quantity, and status, right? See, just by doing the simple exercise, I do have information of S1 and S2 and S3, right? I need to fill in the information of S4 belonging to the city Pune. Can I do that now? Yes. Because it does not have any part, that supplier is a trainee supplier and it is not, providing any part. I do not have to insert anything in this particular table. But I still am able to, put in the information that yes, we have a new trainee whose name is S4. He's from Pune and yet he's not able to, he's there, but he's in training phase, and that's why we do not have any parts, associated with him. So do you see, by breaking down that bigger table into smaller table, you have reduced the redundancy. And second thing is, now you do not have any insertion anomalies. Okay, I hope that makes sense. Now, see, when it's a database, you obviously do the CRUD operations, right? You want to insert something, update something, and delete something. We faced issues in insertion. So obviously we're going to face issues doing updations and deletions as well. Let's talk about the deletion part. Let's say let's come back to the main big table which we have, and now S3 supplier, our S3 supplier ran into some issues and he is no more going to supply us part number 6. So now S3 is not going to supply part number 6. Okay. So we have to do what? Obviously, you will have to remove the relationship between the supplier S3 and part 6. To do so in this table, the only way, I can see 2 ways here. One is I can delete the entire row S3. But if I do so, what will happen is my information that I have some supplier called S3. Might be today he is not supplying me part 6, but might be in future, I might just want to give him a call and say, are you back on supplying with me, with part 6, or are you supplying me some another part, right? So I need to have that information regarding supplier 3, right? I just cannot delete it entirely, right? Second is I could just, make status, part number, and quantity to null, correct? But if I do so, because part number is a part of my primary key here, I cannot make it null, right? Database is not going to allow me because of the DBMS loss. Yes. So here I am not able to delete the information that supplier S3 will no longer provide me part 6. Okay, I cannot do that without actually deleting the useful information. The useful information is that supplier S3 belongs to Hyderabad and we do know a supplier S3. That useful information, I cannot perform, like remove something, unnecessary information without actually deleting the information which I need. This is what is called as the deletion anomaly. Again, The solution for this would be, again, if I break down this bigger table into smaller table, one table which just talks about the supplier information and the another table which talks about the relationship between supplier and part number. If I can have something like this, then definitely what I can do is I can just remove that relation of supplier and part number from the second table. I don't have to do, anything with the supplier information because the supplier is still there in my database, but it's just that he's not providing me any part. Okay, so again, you see, you can also run into deletion anomaly if your relation is not normalized. Okay, fine. Let's come back to the third one, which is your updation anomaly. Let's say now you have a supplier S2 here, and let's say he's relocating from Mumbai. He's going to, let's say, Bangalore. Okay, he wants to go to Bangalore. So in our records, we need to, update S2. And wherever it is Mumbai, we have to, update it to Bangalore. I think we can do that change, right? But think about this. We have how many rows for S2? 2 rows for S2. That means one single update. Ideally, it should have been just one update, right? That S2 is now belonging to Bangalore. But what is happening is because the way we have stored our data, which is not normalized, we are triggering 2 updates. And this is not desirable. Okay, so usually see updation means change of data, alteration of data, right? Usually there are a lot of, you have to be very careful when you update your database. Imagine you just want to update one thing and it's triggering multiple updates. It can be a lot of stressful that you're not really sure what is happening, right? And the reason is here the database has not been designed properly. Okay, again in this, so when you have an updation anomaly, it's a your consequence where your one single update is leading to multiple updates. That is called an updation anomaly. And again, the reason here is because everything, all the data is put together in one table. Okay, it's not normalized, and that's why you're facing this updation anomaly. Instead of that, if we again had 2 smaller tables, one table which only spoke about supplier information and another table which spoke about supplier and part number, then just updating your supplier to Bangalore would just require one update. Okay, so as you see, whenever your database or whenever your relations in your database are not normalized means they still have redundancy. Okay, then you run into these anomalies. You have spoken about insertion, updation, and deletion, right? So it's very, very important, that or whatever database design you do, you make sure that you go through the process of normalization. There are many normalizations, different forms of normalizations which have been defined in theory. Okay, so we have one normal form, the first normal form, the 2NF, 3NF, BCNF, and you have some higher forms like 4NF and so on. So practically in industry, what we use is we try to achieve 3NF. We try to achieve that, like our whatever relations we have, we try to achieve that these whatever relations are in 3NF. The reason being 3NF, whenever a relation is in 3NF, it's mostly, it will never, it's free from all the anomalies. If you have a 3NF relations in your database, you will not come, not run into any insertion, updation or deletion anomalies. Again, it's not, it's not actually possible to have zero redundancy. Okay, we are trying to aim to have almost minimum redundancy possible, and that is what has been satisfied by 3NF. So in industry, if you see, most of the relations are in 3NF. I hope this helps.